Hey guys, I was looking at this problem from the last quiz and I realized that there is a mistake in my posted solutions. I ended up, there are like 2 or 3 people that got docked for having it right, even though I thought it was wrong. I've gone in and changed your grade accordingly. I think everyone should take a look at this though. Basically, I'm going to have to make this a test question now since it's clearly raised such a significant point between student answers. I'm pretty sure I actually had the right answer, and then I was grading someone's who was off, and I second guessed myself and then changed the problem and then wrote the wrong answer. And I know that sounds like a convenient excuse, but I actually had posted solutions that were different at one point, and then I changed them, and I'm pretty sure I confused myself while grading someone else's. But anyway, this is how we should actually solve this problem. So just try to make this kind of quick. So Bill invests $300 at the start of each month for 12 months starting now. If the investment yields 0.5% per month compounded monthly, what is the value at the end of the 12 months? Okay, so what I did in the posted solution is I did the value at the beginning of each month. That is not what we want to do. So I'm going to let S of n, I'm going to set this up. So the end of the first month, he has the $300 he's deposited, but then he also gets this boost of interest, 1.005, from what he's deposited, right? And then the second month, he has the same idea, except for what was in there now gets a second boost. And then he also deposited $300 at the beginning of the second month. So at the end of the month, he gets a interest boost on that as well. And this continues to the nth month, which in this case, where equal to, so this will be equal to 300 to the 1.005 to the n, all the way down to a 300 1.05. Now, where we're going to define Sn as the total amount of money in the account at the end of n months. Now in the original posted solution, I'm not gonna bother changing them. It'll just take me too long to rewrite them and re-upload them. So this is the correction to the posted solutions. But in the posted solutions, I let Sn equal the amount of the money at the beginning of the month. And that is a problem because we fail to account for the amount of interest we get at the end of that 12th month. So yeah, my answer was going to be close, but it's off by just a little bit because the formula I had forgets to basically compound the total at the end of the month. So the formula doing it the right way is this. So that's in the total amount of money at the end of the month. So the sum, if we use the geometric formula, the initial amount, the first month, was this. So S12 is equal to 300 times 1.005 times 1 minus 1.005 to the 12th over 1 minus 1.005. And when you solve that, you end up with $3,719.17. Now this should have been the right answer. And what happened so this is the correct answer, okay? This is good. I'm going to show you what I did real quick so you understand. And I think some other people did this too, because I just kind of assumed that if they had 3,720 that they just did a rounding error. I didn't realize when I was grading it that what happened was we basically had 2 ways of thinking about this. The way I've just shown, which is correct, and the way that I was doing it, which is wrong, which is I think about the beginning of the month. So I'm going to let Sn equal the of money at beginning of month. Okay, and then what does that do? Well, then S1 is equal to 300. And S2 is equal to, so at the beginning of the first month I have 300. At the beginning of the second month, I have the 300 from the month before plus or times the interest rate, it was compounded, plus the amount of money I've just deposited. And I do this all the way to the 12th month, and I'll have 300 times 1.005 to the 11th, because notice here when this was 2, this was 1, right? And when this was 1, there was a 1.005 to the 0 here. So it's always n minus 1. So I have 300, 1.005 to the 11th, all the way down to just 300. And the problem with that is that's true for the beginning of the month, right? So if I think of just want to make sure I'm doing this all right. So then I would say that S12 is equal to the amount at the beginning of the month, which is going to be 300 times 1 minus 1.005 to the 12, because we do it for 12 months. Notice that when you do this, there is n minus 1 terms here, and then this is the extra term. So there still is a total of n terms, which in this case is 12. And this is 1 minus 1.005. Okay, and what does that get me? So I'm going to throw it in my calculator real quick, but I'm pretty sure I'll get the answer I had before. Yeah, you get the answer that I had on the answer key, which is wrong. You get 3,700.67. And see, the problem here is that this is the amount at the beginning, right? The beginning of the month. We want to know what he has at the end of the 12 months, right? Because it's at the end of 12 months. So there's still one more compounding. So the total, the missing step that would have saved the day here would have been to say that thus the total at the end at the end of the 12. Whoops, that is not how you spell months, guys. months. Thus the total at the end of the 12 months is 1.05 times the sum that I had at the beginning of the 12th month, which is then equal to the 19.17, which would have been right. So my answer was wrong because I forgot to account for the last month when I did it. So what you can expect, just to apply this going forward, you can expect that on the exam, I'll have some question where I'm going to ask you, I'm going to say, what's the total at the end of X months and at the beginning So I'll have like some setup and I'll say what's the total at the end of X months and what's at the beginning of X months, mainly to show to me that you've watched this video and paid attention to what I've explained here, and to show that you clearly understand how to use the geometric series to solve both. Because there's this subtle difference here, right? Like there's two ways to approach this problem, and we should be able to understand it through both ways. But you'll clearly recognize it because it'll be the only question on the exam that has some type of setup and then asks you these two things back to back. All right. If you have any questions about this, feel free to bring them up tomorrow in class. Otherwise, I will continue on from where we left off today.